All right, guys, let's go ahead and get started here with our first lesson. This is all about vocabulary, some of the basic terms that we're going to be using this school year that deal with vocabulary. So let's go ahead and get started. Our first up, we have this whole numbers set, and whole numbers are the set 0, 1, 2, 3, and so on. Okay, so we don't have, if you notice, we don't have any negative numbers. However, we do have 0, and then all the numbers that lead up after 0. Okay, integers. Right here it says number line. Think of a number line. Okay, for integers, we're gonna have negatives and we're gonna have positives. Okay, so we'll have -3, -2, -1, 0, 1, 2, and so on. Okay, this goes in both directions. So our negatives will go on forever, our positives will go on forever, and those are our integers. Notice we also have 0 in here as well. So if you look at both of these sets here, it looks like whole numbers are in integers, but integers do not include whole numbers do not include the integers. Okay, so real numbers are actually the set of rational and irrational numbers together. All right, let's keep moving on here. Let's go down to term. Okay, so for a term is a number, variable. Okay, it could be a number, it could be a variable, it could even be a product. Okay, so number, variable, or product of numbers and variables. I know that one sounds a little silly. So term is a number, variable, or product of numbers and variables. Okay, a variable is a symbol that is used to represent unknown numbers or values. And I'm running out of room here, so I'm gonna just abbreviate. Okay. All right. Switch my pen up here a little bit. Hopefully that helps. Looking for a coefficient now. Okay. A coefficient is the numerical factor of the term. Okay. So the numerical. Oh yeah, it's much better. The numerical factor of the term. So I'll give you guys an example here of a coefficient. So let's say we had the term 5x. Okay, we had the term 5x. The 5 would be the coefficient because that is the numerical part of the term. So that's where the number comes into play. Okay, so the coefficient here is the number. Next up, like terms. Like terms are just terms that contain the same variable with the same exponent. So contain the same variable and exponent. Okay, I'll show you guys some examples. So let's say if we had 2x squared and 5x squared, okay? Both of those have an x squared, we would be good there, right? Let's say we were doing, let's go 3x cubed and 4x, okay? These would not be like terms because as you can tell, this one is cubed and this one doesn't have anything there. So like terms, you got to make sure that they have the same exponent if they do have an exponent. All right? Expression. An expression is numbers, symbols, and operators grouped together that show value. So numbers, symbols, and operators. So operators are just like your multiplication, your division, any of those. Grouped together that show value. Okay. If we want to know how to evaluate, we got to know what evaluating is. Okay. So to evaluate, really, that is just to find the value of an expression. Okay. Very good. 3 more on this left side here. If we want to know what an equation is, okay, we're going to be solving lots of them this year. An equation is a mathematical sentence that contains an equal sign. So mathematical sentence that contains an equal sign. All right, next up, solve. If we want to solve, okay, solving is the process of finding all values, finding all values of the variable that makes the equation true. Okay, process of finding all the values of the variable that makes the equation true. Okay, a solution. A solution is a replacement value for the variable. Okay, so a lot of the times we'll say, okay, our solution is x is equal to 6. That solution right there would be a replacement value for our variable. Okay, I'm definitely glad that I changed markers, and I apologize that I did not do that from the beginning. All right, right side here, let's get a little different. Let's use some blue. Let's see what we got here. Coordinate plane. Okay, coordinate plane. It is a plane containing an x and a y axis. Okay, so a coordinate plane has both an x and a y axis. So in order to know what those are, let's go ahead and define those. An x-axis is the horizontal line on the graph. Okay, which means that the y-axis would be the vertical line. All right, now the origin. The origin is the point where two axes, which is just the plural version of axis, intersect. Okay, and the origin will always be 0, 0. Okay, the origin is always 0, 0. So I just gave you an example here of an ordered pair with 0, 0. So let's go ahead and define ordered pair. An ordered pair is a set of numbers used to locate any point on a coordinate plane. Okay, and the way that we write ordered pairs is this form right here. Okay, x, y. So our x goes first and our y goes second, which kind of gives us our definition for these next two. Okay, x coordinate, the first number of an ordered pair. All right, which tells us that the y coordinate will be the second number. All right, cool. Next up, graph. The graph, okay? So definition of graph here, to draw or plot the points named by certain numbers on a coordinate plane. So to draw or plot the points named by certain numbers on a coordinate plane. Okay, apologize for my handwriting. At this point, it is getting a little rough. I'm trying to do my best for you guys. Moving on here. So random math vocabulary, just some random stuff here. Some things we're going to want to know. Square root. Okay, square root would be 1 of 2. Oops, sorry. 1 of 2 equal factors. 1 of 2 equal factors of a number. Okay, so an example, square root looks like this, right? So if we were to take the square root of 100, that would be 10, right? Because 10 times 10 is equal to 100, okay? So this is just one of the 2 equal factors needed to make up the number 100, okay? So that's square root there. Perfect square, okay? A perfect square is a number with a square root that is a rational number. All right. I know some of you guys are probably already knew this, but square root of 100 would be an example of a perfect square because 10 is rational. Now, let's say if we did the square root of 2, okay? What's the square root of 2? Well, it's going to be some never-ending decimal, which would not be a perfect square, okay? So square root of 100 is a perfect square. Square root of 2 is not. Next up, absolute value. Okay, the absolute value is just the distance a number is from 0 on a number line. All right, that is what the absolute value is. And that is normally represented. Let's say if we took the absolute value of 5, it would look something like this. Okay, exponent. So let's say we were going to do 6 cubed. Okay, 6 cubed. Well, this right here, that is our exponent. Okay, so what this does, this tells us, how many times 6 is going to be multiplied by itself. So I'm going to say tells us how many times to multiply the base by itself. Okay, and you're probably asking yourself, well, wait a minute, what's a base? Well, we're going to get to that on the next word here. So here, our base would be 6. Okay, so let's just draw the same example, 6 cubed. Right here, this guy right here is our base. Okay, so that's all I've got there for you guys. Make sure we do take a look at this back page, and we are making sure we get that done. Okay, we'll check that tomorrow. You guys got any questions, send me an email. Thank you very much.